Hey everyone, thanks for checking out my new video. Today I wanted to talk a little bit about my map and how I generate it. Someone asked me on my last video how I go about creating my map. Here it is in the background. I want to talk a little bit about it today. So I actually generate my map using Perlin noise. If you've worked with it before, you can probably tell. And now this area here at the bottom is already created for the game, so it's quite full, but the rest of the map is quite empty. So if I start here at this town, we can see this is actually red town on the map here. It vaguely matches what it looks like in game. We can see the mountains around it and the main town area. But equally we can see that there is some snow to the north of this town and also a volcano area. So if I start scrolling up from here, and eventually we should reach this snow area, which we can see here, and if I keep going up a bit further, we should see the volcano area. And this is just generated using simplex noise. So the mountains you can see, the rivers you can see, and the lakes, they're all generated with simplex noise. And so what does that look like? So I built an application in the web browser which goes and generates the noise for me and allows me to see what that noise looks like before I save it. And this is that application. So this looks like an image right now, but it's not. It's actually being plotted as I load the page. Equally, this river is also being added afterwards, and this road as well. So we can see here we've got the ash area, we've got the snow area. How is that generated? And this is another application which generates those areas for me, as we can see here. So if I make a couple of changes to the ash area and the snow area, it will take a while to regenerate because it's such a big grid. So I'll skip to where it regenerates. And so here we can see it's regenerated both those regions. Now the reason it's only generating the top half is because I've told it to only generate the top half for now. But equally it could fill the whole screen. Now once I've got that data, I actually extract it and add it to this other program which then stacks them on top of each other. And again, this is another program here which goes ahead and generates those regions automatically and creates a new map for us. So I'll set that running and I'll come back once it's generated. So as we can see now, it's generated a completely new map from scratch, and it's also going to add these rivers and roads as well. Now the way the rivers work, it's actually a path find. So I pick a random starting point, I pick a random ending point, and for every node in that path find I just stick down a little bit of blue to say that's a river. And the same with these roads that I've just generated afterwards as well. You can see that they cross grid around the map, but they never actually go over a mountain. And that's just because it's being done through pathfinding. With this being generated by the data, I can just extract that information and know where I should draw a road within my world. So next I wanted to take a look at the code for that. We can see at the top here, it just generates some simplex noise. I am seeding it with the same value every time so that I get the same result. If you know anything about rogue games, or if you develop rogue games, you'll probably be familiar with seeding and always reusing the same seed if you want the same result, and that's what I'm using. I'm taking advantage of that. We can see here in the code, all I'm doing here is generating a map, which is the size of the grid that we have. And then for each individual pixel, I'm making a calculation. I'm making a noise value calculation to decide what should be in that position. Should it be water? Should it be mountain? Should it be volcano? What should that be? So that's the code here. And just a bit further down, we can see I'm also doing a path find. When we say easy star.find path, that's just an A star path find. And I give it a random starting area, a random ending area, and for every node along that path, I will just plot down the water style. So if we go back to the map now, we can see where those roads have been generated and where those rivers have been generated. So another thing I really want to show you guys is what else you can do with simplex noise. So here I'm just pulling up my Twitter, and this little graphic here is actually simplex noise. It may not look the same as my map, but it is essentially the same code in the background. I'm generating simplex noise at certain positions, and depending on what that noise is, I'm returning the value. Even this matrix themed animation is driven by simplex noise. There is no, I'm not saying, hey, for every square, increment the y of that square by 1 every frame. I'm not saying anything like that. I'm simply generating simplex noise and then moving that simplex noise, and based off that simplex noise, representing an image, a circle, a square, something like that. And we can see we can get some really interesting, weird looking animations just from simplex noise. These animations are actually generated in the same tool that I was just showing you for generating my maps, just different settings. Same tool, different settings. So now the next challenge with having such a big map is, how am I storing it? How am I looking at that map? And in my case, I actually use chunks. So if we look at a small map file here, we can see there is region00.json, and that just represents a chunk. It represents the chunk in the top left corner here, and it's just 10 by 10, so every chunk is a 10 by 10 grid. And we can see here these numbers here is the array for that 10 by 10 chunk, and then these are the objects that exist within that chunk. This file itself is quite small because it's actually my development area, which is only a 2 by 2 area, which results in 4 chunks. If I look at my actual real map, VS Code refuses to even look at the document properly. It just doesn't even represent the document. Probably a good thing, because it is around 21 megabytes for the full map. Obviously that's uncompressed, so if you compress it, you can get it down to around 1.42 megabytes, something like that. So this entire map can be generated with chunks, and then I feed those chunks into my game, and that's how I generate my map that is 1,000 tiles by 1,000 tiles. And so, simplex is great. It allows us to generate this map. It allows us to get the areas we want. But really, there's no human structure to it. There's no natural structure to it. It just looks a mess. So actually, I didn't just randomly generate my simplex noise. I was building it with purpose, and that purpose was to match this draft map that I put together a year ago. Simply in a spreadsheet. So I drew this map out, chose a 10 by 10 grid, and selected where I wanted winter to be, selected where I wanted volcanoes to be, and then everything has been based off this map since its inception. So the cities must be where it shows on this map, and the areas must represent the same as that map. And if we look at the original picture again, we can see that does all match up with my ideals. And so yeah, I hope I've shed a little bit of light on my process, shed a little bit of light on simplex noise, and if you like it, leave a comment and tell me what you think. Cheers. I'll also just leave some footage in the background here, scrolling around the map and just taking a look around.